Pixar has made some of the most successful movies of all time. Toy Story, WALL-E, Monsters, Inc., and many others. These movies are made with cutting-edge computer animation techniques that Pixar often has to invent in order to tell the story it wants to tell. Pixar has teamed up with Khan Academy to teach anyone who wants to learn the basics of computer animation Pixar-style. The collaboration with Khan Academy is called Pixar in a Box, and Kitt Hirasaki joins the show to talk about it today. Kitt has worked 2 stints at Pixar, starting in 1996 and again in 2008, and today Kitt works at Khan Academy. So we also get into his experiences at Pixar and how the software engineering at Pixar works. And if you're interested in contributing to Software Engineering Daily, either as a host or just getting involved in the community and helping prepare questions, you can go to softwareengineeringdaily.com and you can click on the link to collaborate. You can also find links to the Slack channel and my Twitter and my email address if you're interested in leaving feedback or just tweeting and saying hi, telling me what's up, what technologies you're interested in, what you want to hear more about, what you want to hear less about. I'd love to hear from you. So with that, let's get to this episode, Pixar in a Box, after a short message from today's sponsor. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable. And Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Kitt Hirasaki is a designer at Khan Academy. In the past, he's worked as an engineer at Disney and Pixar. Kitt, welcome to Software Engineering Daily.
Hey, cool. Thanks so much, Jeff.
This episode will focus on Pixar in a Box, but we should start by talking about your career at Pixar. You worked there from 1996 to 2000, and then you returned for another 4 years in 2008. What did you do at Pixar?
Yeah, so when I started at Pixar, I was my senior year of college, which was back in like 95, 96, is the year that Toy Story came out. So that was kind of a bit of a sea change in terms of like kind of giving birth to this whole new medium and industry. And I had been studying engineering and also computer graphics specifically in college because I'd always wanted to work in like special effects. That was one of my dreams. And so, was very fortunate to be hired on at Pixar kind of in the wake of Toy Story. Then, like the next phase for Pixar was like, okay, we did it. Now we have to do it again. And so they were then like, changing out of sort of this like pure production, let's, pump this first movie out thing into more of a like, okay, we need like a software department. We need like, we need organization to sort of like do it again and make this stuff more standardized. And so I came in and actually I was hired as the first internal tech support person. So I got to ride a little like, I guess this is before Razor scooters, but like a little push scooter like around the office, and was kind of like the front person for the engineering team in terms of working with animators and technical directors and other artists in terms of like tracking down bugs and dealing with issues.
How did the Pixar of 1996 differ from the Pixar of 2012?
Yeah, it's definitely a different place, but I think they've done a amazing job of like keeping the best, or sort of like as they evolve, like keeping the best parts of Pixar and growing those. So I mean, certainly it was smaller back then. I think it was on the order of 200 or 250 people or something when I started, and we were kind of in this wacky building, sort of office space in Point Richmond, which is its own curious little town here in the Bay Area. And I think now Pixar is definitely back then it was sort of just a scrappy company that was doing some cool stuff, and now it's this whole kind of cultural icon, and people around the world know what it is. There's a beautiful building, Steve Jobs Building, which was built I think in around 2000, is now where the offices are in Emeryville, yeah, I mean it's kind of crazy to see sort of how much it's grown and how great it's become.
What about the engineering process? How has the engineering process changed from 1996 to 2012?
Yeah, the engineering process has gone through lots of, I think, phases and stuff over the year. I think, like I said, just coming right out of Toy Story, we were, a lot of work had been done and things had been built just sort of we just need to build this thing so we can make this movie. And so then there was this sort of first phase of okay, let's start trying to Ansify RC. There was a lot of just let's put in some organization and start bringing consistency and stuff to the product. And then throughout the years, there have been various, I would say, there have been various sort of next generation systems that have been built, or that the system has kind of evolved over time. And yeah, interestingly, I don't have a full view because I was gone I was away for 8 years, but when I returned specifically to work on a project, and then as a designer rather than as an engineer, which was the foundations of, which was kind of the biggest sort of next gen effort that had been done, which is the system that's now called Presto, but it was basically the successor to the original system, which was known as Menvi, which amusingly was a shorthand for modeling environment. But the irony was that the way it was used, modeling was the one thing that wasn't really done in that system. Everything else was done in Menvi except for modeling, which was done in Alias Wavefront and Maya.
So what exactly were these tools, Presto and Menvi?
Yeah, so Menvi was kind of when Pixar first came around, there wasn't Maya. There weren't there weren't a ton of commercial packages that you could use for making, animated features. And Pixar had been doing this, had been, building tools and stuff since, in the 80s. And so they had basically built this whole custom software system for making things. I think PDI is another organization which then became part of DreamWorks that was sort of working in this early space, and so they really had to develop all their own tools because there just wasn't a lot of commercial stuff available. And so that's what the Menvi was. Menvi was this whole giant suite of things from originally included modeling, but moved away from that. Had everything from rigging, animation, through lighting, the whole pipeline of stuff where you're working in the 3D environment was lived inside of Menvi.
How does engineering? I mean, you've now spent some time at several different places. How does engineering a movie compare to engineering other products? Yeah,
that's actually there's something really interesting about it. One of the challenges. So one thing about the way Pixar, I think the way Pixar works, because it is a movie production studio. All right. So, and the movie production studio is a giant pipeline. It's like a big factory. It's you've got these ideas and stories that are being created at the beginning. And then as they sort of get ready, it takes about 2 years to sort of do the art, art exploration and story, figuring things out. That takes about 2 years to sort of develop that. And then the next 2 years is basically spent making the movie. And the way it flows through the system, it's it goes through these different department stages, like a pipeline. You've got, sort of departments like sets or characters who are creating, all the different sets that are going to be the thing, or, modeling and rigging the different characters. But then once you get into the shot pipeline, you've got a movie's broken up into sequences, which is sort of a collection of scenes, and then a shot is an individual cut, right, from just between two cut points. And so once you sort of get into shot production, it's going through this very specific flow of first it needs to go into layout, and that's the camera team, and they sort of figure out like what the camera positioning is, what the rough blocking is. Then it goes into like animation, where they do all the animation, and you've got things like effects and simulation and lighting and rendering. And like that whole thing is like this giant pipeline that everything flows through. And then if you have this challenge where like if your story changes or you have to redo things, like crap, like we made a bunch of stuff, like a bunch of stuff came out of the pipeline or was in the pipeline that like now is invalidated. So now we got to like go back to the beginning, like do all that stuff again. So it's this very expensive, like large pipeline that stuff flows through.
But it's funny because the pipeline process kind of sounds like the waterfall.
It is the waterfall process.
It's the waterfall process.
It's absolutely the waterfall process once you get into that shot production world. And one challenge we had with like one story we had when we were working on an early version of sort of the Presto system was this kind of like, we're going to build this sort of like we do a movie. We're going to have this sort of design and brainstorming thing, and then we're going to like go into this and this and this. And we were basically adopting like this waterfall process without like really consciously recognizing what we were doing. And which certainly caused challenges in terms of like things getting disconnected from each other, or, make a design, but that takes a while to implement. And so, since then we've had to sort of recover and figure out ways to sort of, bring stuff in to really close that loop. So you have a much more sort of iterative process on things.
Can you talk about that in more detail? I'd love to hear what are some techniques for making that process more iterative.
Yeah. I mean, one advantage that, and this is for me, like one thing about working at Pixar that like lends itself to doing that is the fact that you are as a designer engineer, like you're creating tools for your coworkers, right? So it's very different than what I do at Khan Academy, where I'm, creating like these like simple, easy to use tools for like anyone in the world who wants to learn something, right? It's very different because I don't like, user research is important, but it's also its own sort of own challenge and sort of figuring that out. And there's clearly like tons of different users with lots of different opinions. When you're making tools like Pixar, though, like, depending on what you're working on, you might be working on like a very specialized tool for like the layout department, the camera department, for like pre-visualizing like how scenes get cut together or how stuff gets laid out or things. And so you can like go down the hallway and talk to the leads there, or whoever sort of the person who's to be in touch with, and like hash it out, figure out like how should this thing work, what should we do, and then make stuff. And they sort of try like, oh yeah, this is good, but I'm realizing like, I didn't really think how important this workflow was, or my other coworker said, oh, this is cool, but like, what about that? So you can have this really tight sort of iterative loop when you're creating custom software like that. Yeah,
the internal customer situation of software development is quite different. It's interesting. I was a software engineer at a trading company for a while, and we were making software for the traders that were sitting on the other side of the room. So if you had a question about, hey, how should I make this option thing work, and you can go and talk to them, and you have a conversation, and you walk back to your desk and like, cool, I just talked to the customer.
Exactly.
Closes the feedback loop. So we're going to get to talking about Pixar in a Box, which is this course, this online course that's in partnership with Khan Academy and Pixar. But I want to talk a little bit more about Pixar first, because Pixar in a Box steps through some of the different phases of this movie pipeline that you're talking about. It talks about them at a more rudimentary level, but it might be worth talking about the different phases of engineering a movie a little bit more, just so when we get to Pixar in a Box, we can talk more about those rudimentary things and how they map to the more grandiose process of building a movie at Pixar. So from a high level, what are the different phases of the process of that movie pipeline at Pixar?
Yeah. Okay, so I'd say, and apologies to anyone if I leave out your department. I don't intend to, because there's quite a few of them. So there's kind of maybe two big phases. One is like pre-production, and one is production. And maybe that term is even just a little off, but the idea is sort of like when I say production, I'm thinking sort of like shot production. So there's kind of the shot production pipeline, which I was describing, and then there's the production before that. So before that, you have things like character modeling, which is actually creating the geometry of the characters. You have shading, which is a term that describes how you do textures and how you make all the different surfaces. And you have rigging, which is providing the controls that the animators would use to actually like move a character around. So around a character, like those are three of the kind of core things there. There's also, I think, simulation has become a very big piece around that. Because the characters are like wearing clothes or have hair or things like that. So that's also a big part of creating characters. On the other side of that, you have set creation. So set has all those same qualities of you're basically creating 3D models and having to shade them and stuff like that. But then additionally, you're like assembling them and like sort of building this whole world. So that's kind of like the sort of those are like the two big elements in terms of production that you're having before you get into shots. Of course, there's this whole other big element, which is creating the story and storyboarding and art design and just like figuring out the look of the film, and which of course that informs like all of these sort of technical and like sort of concrete art departments or sort of specific like production departments. Then once you get into shot production, another thing actually is funny about. Sorry, I'm bouncing around here a little. One thing that's funny about animation production, certainly with Pixar does it, I think the way it is done in general, is editing. Whereas in feature film, sometimes editing is like, oh, we did principal photography and we shot everything. Now we're going to go back and like edit the movie together. Editing at Pixar is like a 4-year epic adventure because it starts at the very beginning. As soon as we're making storyboards and people are drawing, sort of like flip book, comic book versions of the story, the editors are cutting that together and making it into a movie. And so definitely before any like actual shot work is done, anything that you would see rendered out of a computer is done, Pixar creates a whole version of the movie that is just hand-drawn, just like, little storyboards of the whole movie. All right, and then as each shot sort of gets created, as it goes through the pipeline, that editorial cut gets updated, and so you can see just like the whole movie just like evolve shot by shot through these different stages of resolution and everything. So it's a pretty fascinating experience. So then once you get into shot production, typically starts with layout, which I said is sort of like camera and incorporates sets also. Then it goes to animation, which is animation, moving the characters around and other things that move, other sort of like characters and things that move in the scene. You have simulation and effects. Effects also has an interesting relationship with lighting because there's a lot of sort of how it looks goes into effects, like explosions and stuff is a very tight relationship with how things are lit. And then you have lighting, which is, you've got this, in a virtual 3D world, like there's no natural source of light. So you have to put in the lights, or you have to define like what's generating the light. And then the light, of course, interacts with all the surfaces and generates stuff you can see. And then the final stage is rendering. So actually, like, now that we've created these 3D models and all this stuff, we actually have to say, okay, now we need to output this as like a 4K image or whatever, and actually like figure out what color each pixel is and generate the images. And also, like, another thing nowadays is like stereoscopic, like you making 3D movies. There's like sort of a secondary pipeline that's kind of attached on that around like setting up like dual cameras so you can render it stereoscopically. And then rendering, of course, you have to render twice as much stuff for the stereoscopic version, or just like a second eye typically for the stereoscopic.
Okay, that's a great walkthrough. And for listeners who are wondering, why is this topic on Software Engineering Daily? What does any of this stuff have to do with software engineering? All of these different steps involve a lot of different pieces of software, and the software all has mathematical principles that you need to know to utilize, or at least a lot of the artistic software. And I think that brings us to Pixar in a Box. So why don't you just tell us, what is Pixar in a Box?
Yeah, so Pixar in a Box, like you said, it's a partnership between Pixar and Khan Academy and sponsored by Disney. And what it is, it's a series, it's a whole set of lessons on Khan Academy. They're all free. And it goes through, basically the idea behind Pixar in the Box is to sort of see behind the scenes at Pixar. I guess the original picture was sort of like the math behind the movies. So you could see how the things that people do at Pixar connect to things that you actually are learning in school. So the genesis of this was Tony DeRose, who's the lead researcher at Pixar, had been giving a talk called "The Math Behind the Movies," where he talked about because he's a former professor from UW, and he came to Pixar actually about the same time I did originally, and he was a specialist who developed something called subdivision surfaces, which is a way of taking a surface and making a smooth surface out of a polygon mesh. And so he'd been giving talks about sort of hey, we make all this cool stuff, and but it takes math and it takes math and science to actually make these cool images or make build this stuff. And so he wanted to find a way to take this really cool something that was really exciting to kids or to anybody, which is how do you make movies at Pixar, and then connect it back to say, hey, look, this actually things that you're learning in school, especially in math class, connect directly to the kinds of skills you need to have in order to make a movie at Pixar. And so in Pixar in a Box, we look at each of these departments, and I'm actually looking through the list here, and I see crowds is one I left out. So crowds, large groups of people. Within each of these departments, the way the tutorial is structured is that we talk about the job. Actually, a person who works at Pixar. So each tutorial has a different artist at Pixar who's kind of leading and telling you about their job and sort of how they think about this problem. And then we focus on a specific problem or technology that they use that has a foundation, in math or science. And then we dive into that to see, for example, with environment modeling, which is we look at creating fields of grass in Brave, and the grass blades are all, and this is all real stuff. The grass blades are all actually defined by 3 points, which can be used to define a parabola, so a curve. So you've got a little bendy curve of grass, which you can store very compactly because it's just 3 points, and you can also animate that. And so, if you're a kid who's in geometry class or algebra class, and you're like, oh my God, why am I learning about parabolas? This seems like the most useless thing. I can't even imagine where I'm going to do this. And then you see Pixar in a Box, you're like, holy crap! You can make movies and whole look what they're doing with parabolas. This is amazing.
So is the goal to inspire kids to have a carrot at the end of the stick for their math classes, or is it to give students the opportunity to just learn animation and then know what are the engineering principles that you need to know to be an animator? Yeah. I wouldn't necessarily cast it too much into sort of the carrot and stick model of things, but I would just say personally, that was very much that got me to be really motivated to learn about math and to learn about probability and different elements that may be more abstract and harder to see the point of if you're a middle schooler or a high school student. I mean, I think it's a key challenge, just in sort of just education in general. And this is part of why there's a large movement towards what's called project-based learning, where the idea with project-based learning is you have something you're trying to do or make, and then in order to achieve that project or make it happen, you have to learn different things to enable you to do that. So you're not just sort of learning things because it's chapter 6 and that comes after chapter 5 and you're supposed to learn it next. But you have a reason, you're I'm learning this so I can do this thing. And I think, so that's what we're really that's fundamentally what we're trying to capture in Pixar in a Box is oh wow, here's a reason to look, the stuff I'm doing has meaning, or here's a reason to learn this. Oh, I want to I want to be able to animate this thing, or I want to try to do this. If I understand how this works, I could actually achieve that. I think the other really cool thing that we hadn't totally recognized initially was that each of the lessons is given by a different Pixar employee who actually sort of does that job. And a thing that was really cool is that
kids are watching these videos and doing the different exercises and playing with the computer programs and stuff, and they're like, wow, like I didn't realize that there was a job where you could like make dinosaur skin. Like I want to do that. That is so awesome. And so we've heard stories from just classes who've our teachers who've introduced to their classes, and the kids are just like we want to work at Pixar. Like this is amazing. Like I'm so excited to do this stuff.
Not to mention that the Pixar employees that are presenting these modules are really animated, no pun intended. They're really interesting people. They seem like desirable people to work with and learn from.
Yeah, I'll say Pixar is a fan. I mean, I love working at Pixar and have many wonderful friends there, and it is truly a great place to work. Yeah, it's the people in the lessons are just as legitimately interesting and nice, if not more, in real life.
Yeah. So this is kind of a tangent, but do you think people at Pixar, do they see the movie making process more as an art or a science?
I think people at Pixar see it more as an art. There's a lot. I mean, clearly there's a lot of science that goes into sort of like creating this 3D world and making it achieve this artistic vision. But really, like everything that Pixar is doing is in service of storytelling. It's in service of creating this experience and this story that just sort of takes you away. And it's just that, like this happens to be the medium, which is a very beautiful and compelling medium that they work in. But it's really about the story.
Okay, so let's talk about some of these modules that are offered in Pixar in a Box. There's one module called character modeling, and this is how you model a character. And the topic of subdivision is explored. And you discussed this earlier, this breakthrough in animation that is called subdivision. What is subdivision? Why is it so important to character modeling?
Yeah, so subdivision is basically an algorithm you can use to take a geometry mesh. And so if you're thinking about it like a geometry mesh, right? So like a bunch of quadrilaterals, like a bunch of rectangles, or not even rectangles, like quadrilaterals all like in a mesh together, or triangles or whatever. And like if you've ever like played around with just sort of primitive rendering stuff, like you quickly run into this problem where like, oh well, like if I try to make this look real, it looks like a bunch of triangles stuck together, or it looks like a bunch of quadrilaterals stuck together, because the way that interacts with the light, once you actually like have shadows and stuff on it, and reflection or just bounce and all these different sort of light properties, like it looks tessellated, right? It looks like it's this like bunch of little bits of things. And so like one way to solve that problem is to like make more triangles, or like, great, like, let's just like make the mesh like smaller and smaller. But then you have this sort of problem of like, well, yeah, great, your quadrilaterals got smaller, so like you see fewer artifacts, but like now your mesh is enormous. Like the number of points you have to represent that is totally crazy. And so what subdivision surfaces enable you to do is, you can define a few control points, like like the vertices of the subdivision mesh, and then you can apply this algorithm that says, how much do I want to basically like sort of like smooth out the surface that's defined by those by those points. And so instead of having to store like every single point for like every tiny little unit of skin or something you might want to render, you can instead use this. You can apply this algorithm to these points and generate like a smooth surface out of that.
Absolutely, and the module walks through this entire process if anybody's curious. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode, because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/SE daily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/SE daily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. So another thing that surprised me about animation when I was watching these videos, I was also, by the way, I was just kind of find myself surprised at how entertained I was by this. I have no particular interest in animation, except I'm interested in all kinds of things, but animation is not a particular interest of me. But I found myself watching all of these videos because they were extremely compelling, extremely entertaining. And one thing that was entertaining was how useful randomness was. Explain why randomness is so useful in animation.
Yeah. Well, first, actually, I want to give credit to just so we can inject this here. I want to give credit to the people who are really like behind driving Pixar in a box. And there's many people, including all the people who've, sort of you see in the videos. But on the Pixar side, this is originally Tony DeRosa's sort of idea or his genesis. Elise Clademan, who's the head of what's known as Pixar University, which is like our or Pixar's internal way for people to train and learn new things, as well as do things like improv classes and fun stuff like that. The two of them are really the people who came to Khan Academy and said, like, hey, like, we want to make this thing happen. And then on the Khan Academy side, the two main players are Britt Cruz, who's one of our content creators, who's the person who's behind, who creates all the videos, or creates the scripts, edits it, like is producing all this stuff, in conjunction, of course, with like the Pixar video production team and the people in the who are in the video. And then Peter Collingridge is also works for Khan Academy, and he's the one who's created all of the interactive exercises that you can do in Pixar in a box. So like all of like it's just crazy amount of stuff he's made that's like super cool, from animation tools to like he created a whole rigging system. You can like rig your own characters. Like it's really, anyways, I just wanted to give that credit. But back to your question, which is about randomness. Randomness has a lot of utility. I think maybe part of it is that the world is a pretty random place. You sometimes, don't, I guess you don't necessarily, maybe you don't natively think about it. But like, what makes sort of things more realistic and less kind of cookie cutter can often be achieved by just introducing a little bit of randomness. I even remember, this is just my random story of my own, but I remember even like back when I was in computer graphics in college, I was writing a ray tracer, which is a way of rendering images by like shooting these virtual rays to figure out how light bounces around. And I had all these like weird artifacts because the like system I'd set up like was having some problems where it was like, whatever, the rays were like passing through some 0 point at some time and they were getting lost. And I was like, you know what happens if I throw some randomness on here? And so like I jittered all the rays and then suddenly it worked and all my problems went away. I was like, that's amazing. I don't necessarily recommend people just do that. But, as a person who's pulling all-nighters my senior year, like it worked out pretty well.
Well, it's funny because you can use randomness in a random way, but you can also use it in a somewhat deterministic way by bounding the ways that things are randomized with probabilistic strategies. And this is touched on in the Pixar in a Box series. I actually think this is a super important topic to teach to people at any age. Like I think, as humans, this has been well discussed, but as humans, we are not good at estimating probabilities and judging things that are somewhat non-deterministic. We're not good at making expected value calculations based on those probabilistic things. And it's funny because you mentioned drawing the dinosaur skin. I think this was one of the examples where they showed a process where if you put in too much randomness, it looks weird, and if you put too much determinism, it looks weird. How do you find that balance between randomness and determinism, and how do you make a program that does that programmatically?
Yeah, I mean, some of the things like in specifically like the patterns lessons is a place where they talk about the dinosaur skin, and they talk about like the Poisson disk process, where they like are distributing sort of like the different scales in sort of it's not truly a random way, but a sort of randomish way, or like, using that particular algorithm. Or later on, sort of with Perlin noise, of introducing like just these algorithms for generating noise and randomness. And certainly people have done research over time to actually sort of generate these things, and they've been useful. It's like, oh wow, like this sort of simulates something that we see in like real world, like or gives us or perhaps gives us a degree of control that we need, that just sort of like doing random, just something totally random isn't helpful. So in terms of like what tool do you use for that particular time, it's gonna depend a lot on exactly what you're trying to do, and how much sort of randomness or what kind of randomness you want to inject is going to vary, presumably a lot from sort of, task to task.
Okay, yeah. So it sounds like this is just a tool in the toolbox that permeates all steps of the animation process.
Yeah, hopefully, I'm pretty sure that Pixar doesn't do what I did back when I was in It's like randomly jitter their pixels around so they get rid of their artifacts.
Yeah. Well, one lesson that talked about randomness was this module about WALL-E, which is this robot movie, and there were these random combinations of robot parts that were used to generate a fleet of robots, because there was this scene where they wanted to get a big fleet of robots. They wanted to make the robots look somewhat distinct, but they didn't want to design each robot individually. So what they did is they made these, they made like 5 heads and 4 bodies and 3 sets of legs, and it was pretty interesting. The animators talked about using combinatorics to get these different modular parts. How common is this method of finding some structure by using kind of combinatorics and randomness at a higher level like that?
Yeah, I think the world of crowds, is definitely very common there, right? For example, like in this case of WALL-E, you have very explicit like rip off this leg and stick it on like a different robot kind of thing. But even in like a movie like Brave or something, where you're like, oh, there's a whole bunch of characters, like there's these different, like it's set in Scotland, there's like all these different clans who sort of have different looks and stuff. So you need to like generate like all of these different characters. Or Monsters University, that was another one, which is kind of like WALL-E, where it's like, okay, like we've got a university full of monsters, and we have like an idea kind of like of like some kinds of monsters, or sort of monsters look like, but like how can we generate like a whole bunch of extras basically, to be in this scene. And so yeah, people have come up with like all kinds of, there's like a whole like team working on like how can we like make it easy to like sort of have like a monster maker and like generate these different things, all these different versions. And one fun custom they have at Pixar too is they did this for cars also. That's another place where it's like, oh, there's a world of a jillion cars with all different colors and like slightly different this or that, or different models. And they have a tradition of naming the individual like extras they end up using after people at the company. So like lots of the names are like variants of actual employee or artist and employee names at the company. Like they just sort of like, because once you put it in the 3D scene, like you got to give some name. It could be just Monster 54, but why not name it after so and so? So you end up having all these like named monsters, and it's hilarious.
So there was this, speaking of crowds, there was this zombie movie a while ago called World War Z. I don't know if you saw it. And there's this scene in World War Z where Israel has built a giant wall around the city, and all of these zombies are trying to climb over the wall, and they eventually do climb over the wall by climbing on top of each other. And this scene was actually generated by giving these zombie models some rules along with autonomy. What'd you say?
Yeah, sure. Go ahead.
And so this achieved this natural feel by virtue of having a loose set of rules along with giving these models autonomy. Does Pixar use this type of generative animation where you have autonomous agents and you give them a goal and you just have them generate an animation until you get something that looks convincing?
Let me think. I'm not as familiar with that part of the pipeline if they're using that. I would say in general, like Pixar has historically had a bit of a bias towards hand animation or versus like procedurally generated stuff, though lots of things are procedurally generated. I can't specifically think of a lot of places, especially something as like complex as what you're describing.
Yeah.
I can't think of a lot of places where I could point to it and be like, oh yeah, like that shot, that was like a big, like, okay. They applied like the procedural, like, Lord of the Rings big fight scene like thing to that or something like that.
Yeah. Okay. Well, that makes sense. I mean, I think also my understanding was this is a pretty cutting edge technique, and this movie happened from somewhat recently. I think it might have been after you have left Pixar anyway. So,
I've been gone for almost 4.5 years now. So I'm sure they have tools like that do things like that. I just don't know. Nothing is popping into my mind where I was like, oh, like obviously like that shot was done with something like that.
Sure. So given that we're talking about software engineering on this show, the most compute-intensive part of the animation process is probably rendering. What is rendering, and how has it advanced in the years that you spent at Pixar?
So rendering is basically you have all these things in a 3D scene. You have geometry. On that geometry, you have mapped a shader, which is a thing that defines that how light interacts with a particular point on the geometry, and then you have the lighting model, which is different light sources, and that is like tied very closely with shading, like how things reflect or bounce around and stuff like that, and from all those, like that soup of ingredients, right, which is like your 3D scene or your 3D scene description, what you have to do is you say, okay, well now we have to like make a picture out of this. So how do we actually do that? And the way you do it, very like just basically is, every pixel, you've got an image that has just made up of pixels. Like if they're rendering at 4K, it's like 4,000 something pixels wide. So every pixel is going to have a color. And that color is going to be dependent on, like, let's say the simplest case of like, I've got like a ball like a circle in the middle of the screen, right? So if I render each pixel, if I go through each pixel, like if the ball is white and the background is black, then for most of the pixels, it's just going to be black, because when I look through there, what I see is just black. But then when I look through and I see ball or some part of the ball or the circle, like that pixel is going to be white, or some, sort of like a shaded version of white if you have like shadows and stuff like that. And so then that's like the simplest case. But then as you get more complex and you have like a room with blue walls and like a wood floor, and like the wood floor is reflecting the color of the blue walls, and there's like a mirror, and like there's characters, and there's like hairs which have like sort of light effects where it looks like they glow when the light shines from behind them. Like you have all this like complex interaction going in. But essentially rendering is like, from my eye position looking at this scene with like some screen there, like what is the color of each pixel going to be? Rendering has, so I'm not a super expert on rendering, but some interesting things about rendering at Pixar. 3D films become a bigger thing more recently, since like digital cinema. Actually, so 3D was kind of the carrot that distributors and makers put out there to get the like theater chains to like put in digital cinema. They're like, hey, we'll give you these 3D movies if you put in digital cinema, so that we can like beam you. We don't have to send around reels of film, because that costs us a ton to make those, and they get dirty. We just want to like be able to beam you digital data. So like we'll make these 3D movies if you put in digital cinema. Anyway, so that's just like a little random aside.
Interesting.
And so Pixar went back and was like, Pixar started making 3D movies. It was like, oh, okay, cool. And they said, hey, like, wouldn't it be cool if like Toy Story was in 3D? We made it 2D, but maybe there's some work we can do to, like figure it out. And so they put in a bunch of work to like retrofit these, each shot and put in a second camera and make sure it looked good. And then they cover over any cheats they made in the original shots. And then they rendered all those frames. And when they rendered all of Toy Story, it took a weekend. So like, just for perspective,
wow.
like when you're working on a contemporary shot, in at a place like Pixar, that's like really complex. Let's say there's a bunch of simulations, like all kinds of stuff going on. Like, that it would not be weird for a single frame, to take a whole day or possibly more to render. Like that's not crazy. Like one frame, might take that long. But the level of complexity, kind of stays constant. It's almost like a function of like people's sanity or something like that. Like we just keep getting more and more complex. But like the amount of time you like spend waiting for renders, like sort of seems to stay somewhat constant. But
really, the
machine just keep getting faster and faster. Okay, well maybe I might be glossing it over a little bit, but there's definitely something to like the machines get faster and faster, so you can do more and more complex stuff and like still make a movie in like the kind of time you've allocated. But just the level of complexity that can be generated now and then rendered is like just ridiculously greater than what was possible 20 years ago.
And so you're saying that the animators basically keep pace with the improvements in technology, so it still takes just as long to render as it once did.
Yeah.
Or roughly.
That's effectively like, not specifically the animators, but like, that's kind of like the appetite, is like, okay, well, like, hey, we have this amount of time, like we can make it look this good, or we want to make it look this good. Like, yeah, it kind of just in some ways expands, because you could like, hey, okay, let's light this like we were doing Toy Story or something like that. And it's like, okay, well, it's kind of primitive by today's standards. It's going to look dated. So you don't want to do that. You want to like use the latest and greatest. But then the latest and greatest like has a cost, right? If maybe we have like an even better, like super duper way, but if it takes like 10 times as long as anything else to do it, like, well, we just can't do that. You want to have the latest and greatest, but you don't want to spend, 10 years making your movie.
That is Parkinson's law though, right? Because it's like I think Parkinson's law is the amount of work expands to fill the available resources that are there to do that work. So that's kind of what it sounds like.
In some ways, I think that's true. Yeah.
Yeah. So, what about like the cloud? Can you? I mean, I guess I don't know if you can export your rendering process to the cloud, but is that possible, or do you need extremely customized servers to do this?
It's definitely possible. From what I know, so again, I've been away from Pixar a little bit. From what I know, Pixar pretty much does all their own rendering. They have render farms. They have like several big rooms of computers that they use for this. But like I know another guy they've started a new company, and yeah, they don't own any. They don't own any machines other than they're just like, what do they work at their desktops? Like all the rendering they do, or all the the heavy lifting and stuff that happens is all done on like Amazon Web Services or something like that.
So Amazon Web Services offers GPUs that let you.
All right, maybe I don't want to gloss over. I don't know if it's specifically. I don't want to say like,
sure.
Oh yeah, go to AWS because it's used for you to do stuff.
Okay.
But like whatever, there's some like cloud. There's some. There's definitely cloud technology that will enable you to do this, so you don't have to run a damn render farm yourself.
Right. Okay. So this has been interesting, and I've taken up so much of the time talking about random Pixar stuff. Tell us more about Pixar in a Box. What are some of the other modules that we have not touched on?
Sure. So just sort of looking through here, the first module that is sort of in the tutorial is animation. And this is with Rob Jensen, who's one of the animators, and actually a bit of a Renaissance man at Pixar. He can really do anything. And he talks about the basic principles of animation. You get to animate like the little ball from Luxo Jr., which is like one of Pixar's first shorts back in the day. And then the mathematical concept he looks at is Bezier curves. which are basically curves that you have control points so that you can make smooth motion. So you can define smooth motion. So you can have just a couple of sort of key frames where you're like, okay, the ball is going to be on frame 1, it's going to be at this location, and on frame 10, it's going to be at this location. And then you can use the Bezier curves to sort of define the motion of the ball smoothly between those 2 frames. Character modeling. Alonso Martinez is the artist who talks about this, and we talked a little bit about this. This is with subdivision surface and how you actually like make characters. Patterns is with Anna Lacaze and Beth Albright, and that's covering dinosaur skin and shading. So this is shading is like what's the texture and how does that appear?
And the randomness stuff.
And the randomness. And a big part of what they talk about and the sort of principles they're getting into is noise and randomness. That's a lot of the math there. Let me sort of just pop through these. Rigging is, so this is the process, it's also known as articulation, is the process of like actually providing all the controls for how the characters move. And this is with Brian Greene. And it's also like the sort of like thing behind this is not specifically around the math. Actually, there's a good bit around like transformations because that's what rigging is. You've got when you're moving things in general, like when you're like defining geometry in 3D world or like an arm or something, or like just a character or something like that. You've got like translation, you gotta move them to a position. You got rotation, they're gonna like what is their orientation in the world, and then you have the scale, how big or small is this thing. And that's like just very simple. There's all kinds of other fancy stuff you can do with rigging, but those are sort of like some of the basic principles we look at. And then also you can like actually make your own character in this cool like rigging system that Peter Collingridge built. So you can actually like rig, sort of define the geometry for your character and rig it and make all the controls so you can actually like move and like animate your character, which is really cool. Yeah,
and this whole course is also just a great introduction to Khan Academy. If you don't know about Khan Academy, there's videos interspersed with little tutorials that are just in the browser. Basically, you get a sample of the software. Like, for example, you can mess around with Bezier curves and mess around how that ball bounces and mess around with randomness, all with these little JavaScript modules that are just in the browser. So with that, let's talk a little bit more about Khan Academy. You worked in movies and television for many years before you ended up at Khan Academy. What brought you there?
Yeah, so it's funny. It's sort of a long arc that got me there. And in some ways, it's related actually to Sal Khan, the founder of Khan Academy. We're kind of contemporaries in terms of age. And back when I was my senior year when I was in college, when I was trying to figure out what I wanted to do, and I knew I was very interested in movies. I always loved movies and special effects, and wanted to try to do something like that. I was also like talking with video game companies and things, and I had this realization that like, wow, like I'm not really interested in like a number of video games, but I'm really interested in this idea of like educational software. Like I would really be excited to like make software that could help kids learn, that would be fun. And I kind of looked around at like what was out there, and like honestly, like the coolest thing to date, as far as I could tell, was like, where in the world is Carmen Sandiego, which is like it's cool, like people love it, but like it wasn't quite holding a candle to like, oh, like Pixar just invented like this whole new like industry and art form. This was back in the era of sort of like CD-ROMs and stuff. Like educational software was like in general like pretty crap. I hooked up with another undergrad who was at MIT, and she was like, oh yeah, I'm really interested in stuff too. And she introduced me to this book called The Diamond Age, which is by Neil Stephenson, who's known for Snow Crash and a bunch of other sci-fi cool stuff. And in The Diamond Age, there's this, it's called The Diamond Age, a young lady's illustrated primer. And in this book, the Young Lady's Illustrated Primer is this book, which is done in the style of like a Victorian sort of like children's book, where whoever the reader is becomes like the main character in the story. But this book is actually the most like advanced AI that has ever been built. And it's this amazing tutor that like helps you learn whatever you need to learn in your life, but in the context of like this fantasy story that it's taking place in. And that this idea of like creating this sort of AI tutor, which may be backed by a real person or maybe AI, but like and weaving in stories and like games into like learning. I was like, oh my God, like this is like so amazing. But it was like, but this is like not like no one is doing anything like this. Like this is so far away. And so instead I took this path into entertainment and did a variety of things. I worked in Hollywood also. I was trying to work as a writer for a number of years. And then I was working at, the second time at Pixar, and I had like a family friend was like, oh wow, like I've been using this thing called Khan Academy to like, learn some math I didn't learn in high school. And then like some other people I kind of heard about this, and I was like, what is this Khan Academy thing? And then I figured out that I saw Sal Khan's TED Talk, which was sort of a famous one from like about 5 years ago. And then I started seeing like, oh wow, there's like these other companies too that are doing like similar things. I was like, oh crap, like the educational technology revolution is here. Like I got to get on. And then I just realized like, wow, this was a thing that I had really desperately wanted to sort of somehow make happen, but it just didn't seem like the time was right back when I was, originally looking. And then finally I was like, oh my gosh, like the Young Ladies Illustrated primer, like the path has begun. Like, let's get on that train. And was, fortunate enough to be able to join Khan Academy. And we haven't made the Young Ladies Illustrated primer yet, but it's funny because this is a book that Sal gives to people like when they start the company. Like this is like a
Diamond
like,
Age.
Hey, like read the Diamond Age.
Really?
Like, yeah. It's because he read this too, like back when he was in college, and he was like, "Oh man, this is amazing."
So that's
like,
his vision too.
Yeah, in some ways that's his vision as well. Yeah, or like this thing that inspired him to be like, "Oh man, like we got to do this." And so so that was funny. That we both sort of were inspired by that same thing like 20 years or whatever, 15 or 20 years prior. And only now were we like able to start working to like make the scene come to fruition.
So you are a product designer at Khan Academy. And what I find so interesting about your career is you really have touched in all these different areas. And it sounds like at these different places you are just kind of sampling different things and kind of seeing where you can put a lot of impact, whether it's as an engineer or working with animators or being a script writer at the Burning Mac show. I don't know, maybe that was something. Was that just something you were interested in for a while? You said you were trying to break into writing. I'd love to just get a little color on that. Like how have you traversed your career? How have your priorities?
What's up with your damn resume?
What's up with you?
Yeah, I don't know. I'm trying to think if there's like a consistent.
Because look, just to set the record, I mean, my resume looks equally strange and like back and forth. It's like, does this guy even know what he wants to do?
And what do I want to be when I grow up? I need to figure that. Well, one day I'll figure it out, or else I'll just be dead by then. Yeah, I think for me, I've always had a love for movies and storytelling. And that's really what led me through, working at Pixar, working at Disney, creating animated films, and then trying myself to like. And when I worked in the Burning Mac show as an assistant, I was like a writer's assistant. I wasn't one of the staff writers. But I hold this interest in sort of telling stories and making movies. That's just always been fascinating to me. I've also always liked technology and engineering. Both my parents worked at NASA, back in the 60s. And then there's like this other weird, I guess, piece, which is like, I want, I have this very strong desire to help, I don't know, to just make a really positive difference in the world. I'm very interested in both in education and politics. And it seemed like, I was just excited that I would somehow be able to sort of like fuse together sort of like my love of technology and of sort of like storytelling with like understanding people and making something that would enable them to take control of their own lives and really like achieve their own dreams. So yeah, it's kind of like grab bag of stuff, but I think those are like those literally are some of like the key things about my personality.
Yeah, I have a lot of respect for that because I think it takes a lot of the perspicacity or tenacity, whatever word you want to use, to say, oh, I have all this bucket of different interests that are somewhat rivaling, but I believe that they can be complementary eventually. And just throughout your career, you sort of gradually asymptote towards satisfying all those different things that seem somewhat disjoint, but over time they come together. And it sounds like, where you are at Khan Academy has really, it sounds like the perfect role for you.
Yeah, I love being here at Khan Academy, and like my role is sort of like always changing and evolving. I mean, every year the company is growing and changing as well. So I wouldn't say that like what I'm doing is some like magical combination of like every, it's not like the end of some superhero movie where it's like, oh yeah, like all my powers combined to defeat the enemy or something like that. But certainly like different elements or different pieces of that are. I'm definitely pulling on like lots of different experiences to try to do my job and try to make great stuff at Khan Academy.
Okay, Kitt. Well, this has been a great show. Thanks for helping to make Pixar in a Box. I have enjoyed it immensely.
Yeah, I would just say, like, I'm actually a very small part of this Pixar in a Box thing. In some ways, I was sort of the original glue that's sort of like, hey, Kitt, like, we know you're at Khan Academy now. Like, do you guys want to like do a thing? And I'm like, hey, I don't know, like, let's talk to the people who have power at this company. And then but I've certainly been involved in sort of like helping figure out like how we want to do this and giving feedback and stuff. But really, the heavy lifting has been done by other people. So I'm someone who sort of knows both sides of these two worlds, and so I'm getting to play this bridge role. But the true credit for Pixar in a Box really goes to Tony and Elise and Britt and Peter and all the other people who've worked to create stuff for it.
Well, maybe one of those people will want to come on the show we could do maybe a part 2 of this. This is because there's so much material to cover around Pixar and the entire project and Khan Academy as well. So, Kitt, thanks for coming on the show. I want to respect your time. I had a lot of fun doing the preparation for this show. So,
good, yeah.
Really appreciate it. And I find your career very fascinating and somewhat inspiring. So, thanks.
Well, wonderful. And if folks, if you want to check out Pixar in a Box, you can just go to like pixarinabox.org and it'll take you right there.
Great. Cool. Well, thanks, Kitt. Have a great day.
Thank you. You too, Jeff.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.